Read this question very carefully. We will have to use the parallelogram law of vector addition to solve this. So here we have a pilot which is flying a plane from point A to point B. If there were no winds, then the plane would directly go from A to B. But in this case, the question has specified strong winds. And because of that, the pilot points the nose of the plane in this direction, in the downward direction. Which of the choices below best represents the direction of the wind encountered by the plane? So how do we solve that? First, let us draw what the question has given us. P represents the direction in which the nose of the plane is pointed. So it is represented by this arrow. And we also know that the pilot wants to go from A to B. Hence, this arrow will represent the resultant direction in which the plane wants to go. So had there been no wind, then the plane would have traveled easily from A to B. But here the winds are there, which means the winds are going to push the aeroplane. And we have to figure out the direction of the wind. So how do we solve this question? We will be using the parallelogram law of vector addition. Remember what were the steps? Step 1 was to create a parallelogram. Now the parallelogram was to be created using the two vectors. But here only one of the vectors is given, this purple arrow. This green arrow is the resultant. But still, we can create the parallelogram. So how do we do that? So consider this endpoint. We will draw a dotted line which is parallel to the x-axis like this. From this point, which is the endpoint of this arrow, we will draw a dotted line parallel to the x-axis. And over here, we will draw a dotted line which is parallel to the wind direction, which is parallel to this purple arrow. So the two dotted lines will look like this. These three sides will represent the three sides of that parallelogram. And now we can connect the original point A to this point. And if we do that, that will give us the direction of wind. This approach indeed is tricky to understand, but let me explain using another approach. For example, in the question, they did not give you the resultant direction. Consider a question where the wind direction is given and this direction is given. This purple arrow represents the direction in which the nose of the plane is pointed. So had the question given us the wind direction along with this direction, in order to find the resultant in that case, we create a parallelogram and then we had drawn the diagonal and the diagonal represents the resultant. So in this case, what we are doing is we are doing the opposite. So let me repeat what we had done using the resultant arrow and the purple arrow, we had created a parallelogram. So how did we do that? We connect this point where the purple arrow is ending to the end point of the green arrow. This will be the one side of that parallelogram. And the second side of the parallelogram is a dotted line which is going parallel to the purple arrow. And then if we connect the last side, that last side will give us the wind direction. And if you look at all the options now, option B is the right answer. Resultant of vectors at angle bisector. This topic is just to figure out the basic direction of resultants. So consider one vector is given to us along the x-axis and then we have another vector. And both of these vectors are having equal magnitude. In this case, where will be the resultant? We can use the parallelogram law to create a parallelogram and then draw the diagonal. The resultant of any two vectors is always lie between them. So if I draw a dotted line, now this dotted line represents the angle bisector. Let's say the angle between the two vectors was theta. So this is the angle bisector. If we consider case 1 where the vectors are having equal magnitude, then the resultant always lies along this angle bisector. And this is the shortcut which we can use in the questions. Whenever the vectors are having equal magnitude, the resultant always lies along the angle bisector. As opposed to this, let's consider another case where the vectors are not equal magnitude. So we have one vector lying along the x-axis and then we have another vector which is a bigger magnitude vector. Now in this case also we can draw the parallelogram and draw the diagonal, but just remember the shortcut. If we draw the dotted line which is the angle bisector, in this case the resultant will always lie closer to the bigger magnitude vector. Hence, in this case, if we draw an arrow which is closer to the red arrow is basically the bigger magnitude vector. So this green vector is the resultant between these two vectors. Hence, we should know that the direction of resultant is always closer to the larger magnitude vector. Let us consider one last situation where one vector is along the x-axis and that vector is having the larger magnitude and the second vector is having a smaller magnitude. So this also is a case of unequal vectors. So we are going to employ the same logic. Direction of resultant is always closer to the larger magnitude vector. So here if we draw the angle bisector, which is the dotted line, so the direction of the resultant vector will be closer to the bigger vector. So far, we had discussed how to add the vectors a plus b using the parallelogram law of vector addition. Now, using the same law, we are going to subtract. So, a minus b. How do we do that? So, a minus b can be represented like this. So, addition of a and minus b. So, it is a plus, and in the bracket, we have minus b. Basically, we have to add one vector which is a and another vector which is negative b. How do we figure out negative b? So, for that, remember multiplying a vector by minus 1 just flips the direction, although the magnitude will remain the same. Consider this diagram when we are having two vectors a and b. For addition, the steps were simple. We needed to create a parallelogram using the two vectors, and then we draw the diagonal. The diagonal represents the addition a plus b. In case of subtraction, remember what are we supposed to do? We need to add a and negative b. So b vector is over here. Now remember, whenever we multiply a vector by minus 1, it flips the direction, but the magnitude does not change. So let's invert the b in the opposite direction. So this will be minus b. And now we have two vectors a and minus b. Here we can use the parallelogram law of vector addition. So using these two vectors a and negative b, let us create a parallelogram. That's step 1. Step 2 is to draw the diagonal. And this diagonal will represent a minus b. And that is how we use the law of vector addition to do vector subtraction. Let us solve a question based on this. So here we have a car which is moving clockwise in a circular path. The direction of the instantaneous velocities are two times are given, v1 and v2. Which of the following vectors shows the direction of the change in velocity? Pause the video, attempt it on your own, and then look at the solution. Since we have to find the change in velocity, what exactly is meant by change in velocity? It is just the difference between the two velocities. It is final velocity minus the initial velocity. Here the final velocity is v2, initial velocity is v1. That is why we have written here delta v, which is the change in velocity. That is v2 minus v1. Now remember the trick. How do we subtract? We will transform this equation into this form where we have written v2 plus negative v1. Let us proceed. Here v2 is downwards and v1 is rightwards. So using the two vectors, let us connect and create a diagram. And here we have to figure out negative v1. And remember, negative v1 will just reverse the direction without changing the magnitude. So if v1 is to the right hand side, negative v1 will act towards the left hand side. And now we will use the law of vector addition using the two vectors v2 and negative v1. Step 1 is to create the parallelogram, which in this case is the rectangle. Step 2 is to draw the diagonal. And this diagonal will give us v2 minus v1, which is the change in velocity. And now if you look at all the options, it is option C which matches with this direction, and hence answer is C. A car moves south at 20 meters per second and changes direction by moving north at 30 meters per second. Which vector best represents the change in velocity? Now, I will just start with the most common mistake which a lot of students do, since they see 20 meters per second and 30 meters per second, and then they just subtract them, because change in velocity is nothing but subtraction. So once we do 30 minus 20, that will give us 10, which means the answer would be either A or B. But that approach is actually wrong. The flaw in that approach is we are considering velocities and not speeds here. Velocity is a vector quantity, which means it is not only having the magnitude, but also the direction. We are supposed to take care of the direction. Let me explain how do we do that. So the car is moving south at 20 meters per second. So over here, I have drawn a bottom going arrow, which is V1, whose magnitude is 20 meters per second. And then it is mentioned in the question that the car changes direction by moving north at 30 meters per second. So the car starts at this point, and when it reaches this point, this is where the direction is changed, and we can draw another arrow but going upward. So that will be V2, whose magnitude is 30. The question wants us to find the change in velocity. Change in velocity, remember, is final minus initial velocity. In this case, that will be v2 minus v1. V2 is having a magnitude of 30 and it is going in the upward direction. So we are going to assume upward direction as positive. So V2 will be positive 30. But V1, as you can see, is going downwards. So the magnitude is 20. But since it is going downwards, we are going to consider negative 20. So the change in the velocity will be 30 minus negative 20. That is the key factor. And if you solve this, we are going to get 50 as the answer, which means A and B are actually wrong. The answer is between either C or D. And how do we figure out which answer is correct? We go back to the concept of change in velocity, which is v2 minus v1. Now remember, how do we subtract the two vectors? So we will transform this equation in this form. So v2 plus negative of v1. Hence, v2 is fine. We will keep that as it is, but v1 needs to be reversed. So if I draw another diagram where v2 is drawn as it is, but we will draw negative v1. v1 is going downward, so negative v1 will go upwards like this. Magnitude remaining the same. Here we are having two vectors, v2 and negative v1. And as you can observe in this diagram, these two arrows, both of them are pointing upwards in the same direction. And we know whenever two vectors are pointing in the same direction, the resultant is found by addition. So we will add 30 and 20 to get a 50. And the direction is represented by this arrow. And that is why the answer for this question is not C, it is option D.